Hello, this is Tahmina Khan, TK. Today I will teach you what is partial fraction, which is a part of the syllabus of A-level pure mathematics, A-level mathematics pure part. And here I have given the address of blog address, TKMaths is 1, where I have put all my videos together. The links are there with the heading because I am putting up gradually the videos on O-level maths, maths and A-level mathematics. So depending what children ask for, so I make that one first. And secondly, there is a Gmail address. If you have any query, if you want me to explain any particular concept, you can send a mail to me. Secondly, I would like to say in this video, partial fraction explanation, I have taken examples and explanation from Cambridge International AS A-level mathematics. So this is my reference material which I have taken from that book. So let's see what is partial fraction. To understand partial fraction, we need to understand the meaning of few terms, and those are algebraic fraction, algebraic proper fraction, and algebraic improper fraction. Now in junior classes we have learned that proper fraction are those in which numerator is smaller than denominator, and in improper fraction numerator is bigger than denominator. Fraction we all know which are in the form of numerator and denominator. So algebraic fractions, fraction which has numerator and denominator in the algebraic form. For example, you can see here, you can see here. So these are fractions but they are in the algebraic form. Now what is algebraic proper fraction? Now if you look at this polynomial and this polynomial, the degree here is 3 and the degree here is 1. So degree is the highest power of the variable in the polynomial. So if the degree of the polynomial is bigger in the numerator compared to the degree of the polynomial in the denominator, that it is called improper algebraic fraction. In the case where it is same, like if you see 3x over x minus 5, the degree is 1 in both the cases. So this is also improper fraction. So they both are the example of improper algebraic fraction. Now let's see this example. Now if you see here, the highest degree is 1. If you multiply x by x, it will be x square. So degree of the polynomial in the denominator is 2. So numerator degree is smaller than the denominator degree of the polynomial. So this is an example of proper algebraic fraction. So now we know the meaning of the three terms, which are algebraic fraction, algebraic proper fraction, and algebraic improper fraction. Now what is partial fraction? Let's see that. You have solved in class 10 simplification of these type of questions. These functions, these fractions you have simplified into single term. Now partial fraction is basically a reverse process of this. You will be given a single fraction and you will decompose it. You will split it into parts. So partial fraction is a process to split or decompose a single algebraic fraction into two or more partial fractions. So there are 4 cases we will study. So 3 cases are on proper algebraic fraction and 1 is on improper algebraic fraction. So let's see one by one those cases. Now here I would like to say that the cases depend on the type of denominator we will have. So in case 1, proper fraction where the denominator has linear factors, distinct linear factor. You can see this example. So how we will decompose it, I will show you later. First I will tell you the 4 types or 4 cases of partial fraction. So what will be the denominator in each case? Okay, so this is a proper fraction. You can see power is 1 of the x in the numerator. And here if you see, the degree of the polynomial is a square. If you multiply 2x by x, it will be x square. So this is a proper fraction and both the factors are linear. Now what is case number 2? Case number 2 is a repeated linear factor. Again I am telling you, we decide seeing the denominator. What are the types of the factors in the denominator? So let's see this example. 2x minus 11 over x minus 4 whole square. So when you have a linear function and there is a power overall on the function, it is called a repeated case. So we will see this also later on. So let's see the other two cases. Okay, one more example here. If you look at the second example, this is a linear factor and this is a repeated factor, right? Repeated linear factor. So in algebraic fractions, you may have in the denominator linear repeated together also. So how we will simplify it, how we will decompose them, we will see it later. Now case number 3. Case number 3, in the denominator of the proper fraction, proper algebraic fraction, you will have a quadratic factor which cannot be factorized. So let's see here. If you see this algebraic fraction, the highest degree of the polynomial in the numerator is 2, whereas if you multiply this by this, it will be cubic. So this is a linear factor, this is a quadratic factor. How do we decompose it? We will see it. Now the last case. Last case is improper fraction. Now what happened in the improper fraction, like I have shown you earlier, that we will study two types of linear factors. The one which has numerator and denominator with the same degree of polynomial, and the other one in which the numerator has a higher degree compared to the degree of the denominator. But this is not the part of the syllabus, so we will focus on this one only, in which the numerator and denominator have the same degree. Now when we are solving improper fraction, algebraic fraction, we must first express it at the sum of the polynomial and a proper fraction. So basically we are dividing it into two parts, a polynomial and a proper fraction, and then proper fraction we further split. Now what do I mean by this? When I will simplify a single algebraic fraction, this one you will understand. So let's start with case number 1, in which we have both the linear factors in the denominator. Okay, so this is a single algebraic fraction which you have to decompose. It means you have to find the partial fraction of this single algebraic fraction. Now first of all, you will always see, is it proper or improper? So it is proper fraction, power is 1, whereas if you multiply it, it will become 2x square, which will have power 2. Now case number 1, when you have two linear factors, always remember when you are decomposing it, on the top of each linear factor you will write a single alphabetic letter. Now A and B, it's not fixed, it's just like any letter, whatever you like, you write here a single letter, right? So it means when it will be decomposed, it will take this shape. So now remember, if it is a linear factor, you will write one alphabetic letter on the top of each. After that, you will take LCM of this side. You know how to take LCM. This is a prerequisite knowledge. You should have it. And then, because denominator is same, so we are just writing numerator. Now there are two ways to solve it. One is comparing the coefficient method, another is substitution method. I will teach you both method in this question by comparing the coefficient. In case number 2, I will take the case of substitution method. So in comparing the coefficient method, we expand the brackets, and then I will compare the coefficient of x first. For example, 2 is equals to a plus 2b. This will give me equation number 1. After that, I will compare the constant. Constant is also called x naught. So it is minus 13 and this side minus 3a plus b. So now I will solve two equations simultaneously. All of you know how to solve simultaneous equation, and then I will get the value of a and b. So here I have solved two equations simultaneously. Value of a is 4, b is minus 1. I will plug in these values in this partial fraction, right? So it will become 4 over 2x plus 1 and minus 1 over x minus 3. So let's take, I hope you understood this case number 1. I'm repeating, when both the factors are linear, you are decomposing it individually on top of each, you will write a single letter. Now let's take case 2, which is called repeated. And in the repeated denominator, repeated factor, which is in the denominator, you will do what? You will increase when you are when you are writing it in the split form, the first denominator with power 1, the second denominator with power 2. In case if I had here 3, then my third will be x minus 4 power 3. So you basically write the repeated linear factor one by one with increasing power, and on top of each in the numerator you write a single letter. Okay, so after that you will take LCM, and we know that the LCM of these two denominator will be this. Now it will be equals to 2x minus 11, because denominators are same, we can avoid writing it, there is no need. So numerators we are writing, and I said I will do now by solving substitution method. So by substitution method I will take the value of x, for example 4. Why I am taking 4? When you are doing substitution, you try to eliminate them terms which simplify your working. Otherwise, because it is an identity, when we are writing in the split form, we are actually saying that this thing is equal to this thing, right? So, and it is true for all values of x. It's like an identity. So that's why we can take any value of x we like. It will be true for all values. So now I'm taking first value x equals to 4 just to make my working simple. So it will become b is equals to minus 3. So next value I will take, for example, I can take 1, I can take 0, whatever I like. So I will take x equals to 0 in the next case. It will also help me to simplify quickly. Okay, so now in the identity I have taken x equals to 0, and I end up with a equals to 2. So now I have the value of b minus 3 and a 2. So I'm writing it in the partial fraction form. So replacing a by 2 and b by minus 3. So this is the partial fraction of this single fraction. Let's take another example. It is this one. It is again proper fraction. The degree of the polynomial is 2 here in the numerator, whereas in the denominator, if you see in the numerator, the degree of the polynomial is 2, and in the numerator it is cube, because we have quadratic and linear. So now it is again a proper fraction. So how it will be decomposed? We have just seen in the linear case, on the top of linear factor we write a single letter a, and then on the repeated case we keep increasing the power on the denominator, but on the top we write a single letter. So I am writing here b and c on the top of 2x plus 3 and 2x plus 3 power 2. After that I will take LCM, and when I will take LCM I will get this form. Now it's up to you, either you solve by comparing the coefficient method or by substitution method. So I'm not solving it here because I have just explained both the methods here, so you can try yourself. When you will get ABC, just plug in here on top of this and you will have your split or decomposed partial fraction, right? So let's see the third case, which is quadratic. Okay, so now this is the third case, quadratic factor. If you look at the denominator, this quadratic factors cannot be written into linear factor. So this is the one which will remain as it is. So how we will write it in the decomposed form? Okay, so here you have a linear and a quadratic. So on top of linear, definitely you will write a single letter, whereas on top of quadratic you will write bx plus c. This is the generalized standard form, so you have to remember this. So after identifying that you have linear and quadratic, on top of linear write a single letter, and on top of quadratic write bx plus c. After that you will take LCM. So this will multiply by x square plus 2 and this will multiply by x minus 1. So now I am applying comparing the coefficient method here, And why I'm solving this question, whereas I did not solve the previous question, I'll just explain you the reason. Because the student mostly get stuck after comparing the coefficient when they get three equations and they all have letters, like for example AC, BC, AB, and now they get stuck how to solve it simultaneously. So do you remember how to solve it when you have three equations and three unknowns? Have you ever solved it? Okay, so for example, the technique is from from equation 3, I make A a subject. Then I will have -1 minus B, right? And the value of A, if I plug in here, then this equation will have B and C. I'll show you. I'm just telling you verbally and then I'll show you in writing also. So I'll make A a subject here. I will get -A minus B, which I will plug in here. Then this equation will have BC and this already has BC. So I will solve then equation 1 and 2 simultaneously. I will get the value of BC and then it's easy to find out A. So this is exactly what I have done, what I was telling you. I made A a subject, that is -1 minus B, and I substituted in equation 1. I'm telling here to the examiner or to the paper checker okay, which equation I'm using. It's always better to keep identifying the equation. So I got the equation in terms of B and C. Then I'm solving equation 2 and 4 simultaneously. And after solving it simultaneously, I got the value of B and A. Now using these two values, I'm plugging in equation 1 and I will get my value of C from here. So now I have the values of A, B and C. So those values of A, B, C I will plug in here. So A was 3, I will write here 3. B was -4, which I will write here, and C was -2, which I will write here. So now here I have plugged in the values and here I have just simplified by taking minus common out, which is here, and this will become plus. This is how you will split a single algebraic fraction into partial fractions. Depending on the denominator, you decided which case it is and you will simplify. Now let's see the last case of improper fraction. Now this is an example of improper algebraic fraction, and I told you that in our syllabus, A-level syllabus, we have improper with the same degree in numerator and denominator. And I told you that in that case, first of all, you express this single fraction as a sum of polynomial and proper fraction. So I'll do that by long division, for example. Okay, there is another way also, but first I'm doing it by long division method, and I'll teach you other method also. So I'm dividing it. I have already told you, explained to you in my earlier video how to do long division. So I'm applying the same method and I am getting 7. So it means 1 plus 7 over this. So I have gotten a polynomial and the proper algebraic fraction. Now this proper algebraic fraction you will solve by the one of the three cases we have just seen, depending on the denominator. So at a glance it looks like an quadratic. Yes, it is quadratic, but it is a quadratic which can be simplified into linear factors. So if you can simplify the quadratic into linear factor, you will do so, and then it will become a case of the linear factor denominator. So when you will simplify it, you will write A on top of one factor and B on the top of the other factor. Now forget this one for the time being. We are just dividing or decomposing this into simple partial fraction. Okay, so because we have already discussed in detail, I am taking LCM, and after that I am simplifying by comparing the coefficient method. I don't think I need to explain. I have just explained you in the previous case. So I am comparing the coefficient method and I got the value of B. This value of B, when I will plug in here, I will have A with the same value but with negative sign. and then once I get a and b, I will plug in these values here. So this value will be minus 7 over 4x plus 2 and b will be 7 over 4x minus 2. Okay, so now we have the value of a and I am plugging in the values of a and b in the partial fraction here. So this is the split of this single algebraic fraction. So our actual question was to simplify this algebraic fraction. So one we got with the help of long division, and here it is the partial fraction which we have derived from here. Now I told you there are two ways to do. I made use of long division to get this constant. If you don't want to do long division in case of improper fraction, what else you can do? Let's see here. When you identify it is an improper algebraic fraction which has the same degree in the numerator and denominator, then you can write it like this. You know you will get one constant by long division, so in place of that you write a, and here you will decompose it depending on the denominator. In this case I have both linear, so I am writing a single letter on top of it, and after that I can take LCM. So now I am taking LCM. It is little untidy, so please excuse me. Basically I have taken LCM. A has denominator 1, so it will be multiplied by both the denominators. So after that I am not solving here. You know the technique, I have discussed in 3-4 cases earlier. So now you can solve it easily. So at this I will end the video. So this is the whole explanation of the partial fraction. This topic is integrate with binomial also. So in my next video when I'll explain binomial, and it is also used in integration also. So in my next video I will explain you those two concepts. So I hope you understood. If you like it, if you have learned something from this video, so please do like it, press the button of like, and do subscribe, so when I make my new videos it can give you an indication immediately. Thank you very much.